In these problems we have some rational expressions, and we have to multiply some of them, we have to divide some of them, and we're trying to find the most simplified form that we can find. The trick here is to think about factoring things and to know about the difference of squares and the difference of cubes. So if you need some review on those things, that is going to help you quite a bit. Let's take a look at this first one. These are just multiplied together, so I can kind of just leave them the way they are, and I'll be allowed to cancel things as long as there's one on the top and one on the bottom, whether they're on this side or this side, since it's all multiplied together. If I look on the chunk here on the left, there's nothing I can really do. That's just how it needs to stay. That's as simple as it can be. And over here, well, on the top I've got a difference of squares. And remember, the difference of squares says a squared minus b squared equals a minus b times a plus b. So in this case, this is our a squared, so a is going to be 2y. And this is our b squared, so b is going to be 3x. So I can factor that out into 2y minus 3x times 2y plus 3x. Now on the bottom, we've got a quadratic there, so it would be helpful if we could figure out if we can factor that. And let's see, what if we did 2x plus 3 and x plus 2? We would get 3 and 4. That would add up to the 7, and 3 and 2 would multiply to the 6. That looks like it works. And now let's see what we can cancel out. I notice I've got an x plus 2 up here and one down here. I've got a 3x plus 2y. Here I've got a 2y plus 3x, but you should know that's the same thing. You can put those in any order. So those two would cancel. And what we end up with is this expression right here, 2y minus 3x over 2x plus 3. Much simpler than what we started with. Let's look at this next one. Here we have a division problem, and the only trick here you need to know is you know, with fractions, if you wanted to take 1/2 and divide it by 1/4, you would actually convert that to a multiplication problem. You would say 1/2 times 4 over 1. You take the reciprocal. So we're going to do the same thing with this. First is turn it into a multiplication problem. So let me rewrite this. We've got q squared plus 3q minus 18 over q squared minus q minus 6. And this is going to be times, and I'll take the reciprocal of this. So on the top we've got q squared minus 3q minus 10. And on the bottom we've got our q squared minus 36. All right, so that's the first step. Now we need to see if we can do any factoring with this one. And let's see, on the top here, that's a minus 18. So we could have q plus 6 and q minus 3, I think. And that seems to work. On the bottom here, what have we got? So q minus 3, q plus 2. That seems to work. And now here on the top, let's see, how's that going to work? A 2 and a 5, I think. So q minus 5, q plus 2. And on the bottom we've got a difference of squares again. So this is going to be q minus 6 and q plus 6. All right, I think I did all the factoring correctly there. So let's start canceling. Let's see what we can get rid of. Here's a q minus 3 and a q minus 3. Here's a q plus 2 and a q plus 2. Here's a q plus 6 and a q plus 6. So again, we come down to something quite simple, q minus 5 over q minus 6. And that's the answer for that one. Let's look at a couple more. So here on the top we've got x squared minus 1, and you should recognize that as a difference of squares. So that can become x minus 1 times x plus 1. On the bottom we've got 1 minus x cubed, and actually you should be able to recognize that as a difference of cubes because, you know, the cube root of 1 is 1, 1 cubed is 1. And in case you haven't seen difference of cubes before, here's the formula. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So that's our formula for the difference of cubes. So in this case, a is 1 and b is x. So let's go ahead and plug that in here. So a minus b is just going to be 1 minus x. And then we'll have a squared, that would be 1, plus ab, that would be 1 times x, or x. And then b squared would be x squared. Now, at first glance, it might look like you can't factor anything here. I've got a 1 minus x down here and an x minus 1 up there, which look tantalizingly close. And in fact, if that's what you're thinking, you're on the right track. If we factor a negative 1 out of this, I put a negative 1 out here, then what I do is change the signs there. And negative x plus 1 is the same as 1 minus x, because I could reorder that. So this then will cancel with that. And all I've really done, that negative 1 out here, I could put that as a negative sign in front of the whole expression. And then on the top, I've got x plus 1. And on the bottom, I've got this, well, let me rewrite it in descending order here, x squared plus x plus 1. And I think that's as simple as we're going to get that one. All right, one more. Now here we've got x squared minus 16, obviously a difference of squares. And on the bottom, 256 minus x to the 4th, which is definitely a difference of squares. In fact, this is going to turn out to allow us to do a difference of squares a couple of times. So let's see how that works. On the top, difference of squares, we'll have x minus 4 times x plus 4. And on the bottom, the square root of 256 is 16, so we'd have 16 minus x squared times 16 plus x squared. Now this part right here is the one we're going to keep going at. So let me rewrite this. X minus 4 times x plus 4. And this is a difference of squares. It would be 4 minus x and 4 plus x. But we also have this chunk here still, 16 plus x squared. Now, at first glance, again, it may seem like there's not much you can do, but aha, I've got an x minus 4 here and a 4 minus x here. So if I factor a negative 1 out of this chunk, I get negative x plus 4, which is the same as 4 minus x. That cancels. So I'll go ahead and make that negative 1 a negative sign in front of the whole expression, and I have x plus 4 over, oh wait, x plus 4 and 4 plus x. Ha! So actually, I just have 1 over 16 plus x squared. Much simpler. So that is a little bit of work with simplifying rational expressions.